So I think we're just going to go ahead and get started because I appreciate that you all came all the way down this hallway. And walking down here, I'm like, I feel like I'm halfway to New York. So thank you for coming, especially on a Sunday. I know that Sunday attendance is usually less because people are traveling, like we were talking about, and different things. But I appreciate you being willing to come on out and spend your time with me, and hopefully we make it worth it. So my name is Sarah Young, and I am the author of The Gourmet Lab. And one of the things I always like to start with, because it's the first question I tend to get asked about this, so are you this amazing chef? I'm actually terrible in the kitchen. And you wouldn't necessarily see that coming, but I think it has to do with the scientific streak in me that wants to edit all of the different recipes as opposed to trusting that Rachel Ray knows what she's talking about, and that I shouldn't sub in and sub out different pieces. So even though cooking wasn't my forte, it's something that I've always had a real interest in. And to be honest, this generated from kids' interest and being able to build buy-in with the kid community to be able to engage in some of these science concepts that it had been a little bland before. So that's where I'm coming from. Today we are going to talk about the benefits of utilizing food in your classroom and how to do that in a way that's safe and engaging. We are also, like I said, Safety 101. Some quick food-based activities that aren't in the book but are easy things that you can incorporate into your classroom to start to get your feet wet if you're like, yeah, I want to give this a try. We will highlight a couple of the food-based labs for content to talk about how they break down so you know what that resource is when you're going through it. And then last, just kind of NSTA Press, highlighting some of the other things that they have there, especially a lot of the free content, which I'm not sure our community realizes how much is available there for free that you can take access of as a teacher, and it's a heck of a lot better than a Google search. So basically, just to give a quick background, I graduated with my BA in environmental biology from the University of Colorado at Boulder. I actually came out here to Boston to do my master's in a collaborative experience, and I think, again, that's what makes me a science teacher is I was all about that hands-on learning, and Lesley University was one of the first universities to pioneer that kind of master teacher apprenticeship model approach. From there, I'm an 8th grade science teacher from the state of Utah and now work as the Utah State Office K-12 education specialist. So yep, they've put me in charge out there. But it's something that I've been in for about 2 years, and I work with teachers in professional development as well as members of the community, universities, things like that. So in terms of experience in education, I want to start with this. Turn to somebody next to you, make a new friend, introduce yourself, and just tell them briefly in 1 minute what your favorite K-12 science experience was. So thinking back to your K-12 experience, what's your favorite thing you remember about science? You have 1 minute. Ready to go. So the reason that I ask you to do this is because I think it's always important, especially if you're a science educator, to have that good experience to refer back to. Mine was a bean in a bag experience. How many of you have done this, where you take a bean and you soak it between 2 wet paper towels and you put it in a plastic bag and you hang it up in the window and you start to see kind of the bean will swell and then a root comes out and you start to get a little stem. About half the kids will mold, but mine didn't, and I was like, woohoo, success. And from there, I actually got to plant it in my little styrofoam cup. It continued to grow, one of the very few. I took it home. I was like, look at me go, science in action, as a 3rd grader, and I really enjoyed it. Whenever I ask this of individuals, be it teachers, be it university professors, be it just general members of the public, we talk about the experience that we engaged and interacted with. I've never heard someone say, man, that textbook changed my life. Or that worksheet, oh, just got me. And I think it's important to be able to foster those experiences with kids in the classroom. So the one thing I encourage you is if you had trouble thinking of yours, try and spend some time actually thinking about it. Because for me, that created the goal that I strove for every day. Was every day a bean in a bag experience? No, it wasn't. I was the first to say that. But it gave me something tangible to work towards, which helped me as a teacher to continually try and change things up to be able to meet the needs of kids. So when you're talking about really engaging pieces, a lot of you will start to kind of come back to this idea of, does it connect to me? And so from that, when you talk about science, how do you celebrate holidays, birthdays, other special events? With food. It's true. How many of you have like your favorite meal that you get on your birthday? Or maybe you have that like favorite home cooked thing that you always come back to Thanksgiving for. It is something that our society gets around. It invokes emotion, it invokes a sense of community, and it is something that is really, really prevalent no matter what your culture. As part of that, I think sometimes we as teachers have a hard time being able to relate. Why is this science important to you? Why do you need to know this? Well, you need to know it for the end of level state test. As a kid, that's a hard bargain to buy into, because I'm like, do I get money for that? Is there some sort of like box they check that says like, wow, this kid was amazing in 6th grade? They don't. And so it's important that we as educators draw experiences back to them that help them connect what we're talking about in science to the world around them. It has historical and traditional connections in our society. If you're looking to do things that are interdisciplinary, food's a great place to start, because it gives you that opportunity to do outreach to some of the other topic areas, be it your home ec person or to your history or to English, and to be able to start build those cross-curricular units and themes around what we do with food. One of the best things I ever learned as a teacher was going to the English teacher and being able to say, hey, can I just have your directions for what you do for literacy? Changed my classroom, blew the minds of my kids that, oh my gosh, do you guys talk about what we do? And it was so disheartening to me to think that they see all of our subject areas as incredibly separate, as opposed to part of a collaborative experience. It can also be translated, like I said, economic sustainability discussions in the classroom. If you're looking at a way to bring in a little more about outreach and kind of community service, food's a great way to do it, whether it's a community garden or it's something talking about the drought that's causing the lime prices to go sky high right now, right before Cinco de Mayo. There are lots of different pieces that make food relevant in the culture that we are in today. And last but not least, it has universal impact and context, all right? It's something that exists no matter what they do on a daily basis. These kids are consuming food. So it's not like, oh yeah, no, I've never seen that before. It's part of their daily life experience. So then let's step into it. So benefits of food in the classroom. Again, that context for student learning that we talked about, it really promotes curiosity and innovation. All right, when you're talking about food, there's a product you're striving for. You want the best popcorn out of the classroom. You want and are invested in what's coming up in the process, whether you're making cheese, popcorn, pretzels, no matter what it is, the kids want it to be successful. And as part of it, they're a lot more willing to engage in looking into these concepts. It does improve lab technique, like I said, with measuring and precision. I used to always encourage kids, like, be precise, when we would do a lot of these chemical reactions. You know, sometimes they were more or less, they'd spill, you know, there was a little less buy-in, whereas when there's a final food product, they were all about it. And they were like, yes, I am paying attention and I'm going at it with accuracy and precision. It does promote all of the observation senses, so whether they can taste it, touch it, see it, smell it, measure it, it's all there and it's all engaged in food, and you can do this with kids. And it translates learning from the classroom to home. I think that was probably the biggest piece that kept me headed down this path of developing all of these different pieces, was that all of a sudden there were people from my community who would come in and say, hey, I hear you guys were making cheese the other day. Is that something that we could do at home? And all of a sudden, they were willing to translate the experiences from classroom to the home to create that buy-in and connection, especially with families who didn't come from a science background. But it empowers those parents to say, you know, I do this on a daily basis. I know what this is. And all of a sudden, then I feel like I can have a conversation with my child as opposed to being worried about maybe I don't know all the science terminology, so I'm gonna avoid. So food in the classroom. I know, this is like against every single rule in every single school and every single lab safety thing that ever comes out. But you're looking at a convert. When I started this, it was in a math classroom where I watched them doing observations in regards to some different apple slices. And I was like, no, you can't do that. You can't have food in the classroom. That's against the rules, all right? But I went in, and just to see the level of engagement that kids had when it came to being able to interact with something they were familiar with as opposed to a chemical in a bottle made it worth something that I was willing to try. So in terms of trying it, I think it's important to note that safety is the #1 thing when it comes to food in the classroom. And that's why it's chapter 1 of the book, and that's where you got to start, which is really about how do you prep your environment and your students for being able to engage with food in the classroom, because it's different than most of their normal science experiences. So let's talk about a recommended environment. The consumer science laboratory would be ideal. How many of you have access to that? No, okay, neither did I. And so that's okay if you don't have that. It's just something that NSTA wants to make sure that if you have access, that you're making use of that first. A home economics kitchen works as well if you have one of those. I didn't have any of that. So to note, you can have students complete the labs without eating the final product. I started here because this was the materials I had in class. I knew I just couldn't guarantee that they were safe enough to be able to roll with. I gotta be honest, you better be bringing something in like that you can have on your classroom side that then matches what they're making so that they can eat it in a safe environment. If you don't allow them to actually taste food, it just loses some of that credibility. The other thing is to utilize separate lab equipment for these experiences. I know many people are like, whoa, that would be so expensive. So the way I did it was every year when I would have to repurchase beakers or different things or, you know, different lab equipment, I would always set 1 or 2 aside and I'd label them as food safe only. And so slowly but surely over a couple of years, I was able to build enough that I had a full classroom set that we would be able to use with students so that they could actually engage and eat those pieces. If you start with demos, especially in regards to that, it gives them that opportunity to come and to taste, and you can grow it then to a full class environment. So science is really the study of what's around you. So let me just give you a quick example. This is something that we would do as a demo for thermal heat exchange. It's called It's Getting Hot in Here. Does anyone remember Nelly? Yes, yes. I used to say, no, most people were like, no, I don't remember. This was a song, in case you're wondering, if you want to get on iTunes. I wouldn't necessarily say it's K-12 appropriate. What we are going to do is pass around some M&Ms so that every single one of you can engage in a very simple and safe science experience. And you'll get some chocolate in your blood, which is Sunday morning. You're still here. I feel like you deserve. All right. Does anyone remember the phrase that was kind of the running tagline for M&Ms? What was their selling point? Yeah. So we are actually going to test that here today. All right. It's supposed to melt in your mouth, eh?
Thank you.
You are welcome. All right. So has everyone got an M&M? You got to have at least one. All right, so here's what we're going to need to do. I'm curious, does it melt in your mouth? Okay, because they say it does. They say it doesn't melt in your hand. I've actually had them melt in my hand before. How many of you have had that happen? Okay, you probably live in a warmer environment. I like it. It was yesterday like freezing for anyone else here in Boston. Oh my gosh, I felt like we were doing so well, and then that wind would hit, and I was like, ah! So I'm pretty sure these wouldn't melt in your hand here. But in terms of does it melt in your mouth? So we're just going to do a quick experience where we're going to put it in our mouth and see how long. How long does it take to melt? All right? Now, before we do, is there anything we need to agree on? Oh, somebody's already started. That's okay. Anything we need to agree on before we try this? If we're all going to be able to share our data in a way, what? Same color. All right, we're going to make a call for color. Not everyone has these colors, but what are we thinking? Green? I've got green in my hand. You don't have a green? I think we're all sharing. All right, so we've all got a green. All right, anything else? We all need to start at the same time. I'd agree with that. Ooh, same place in our mouth. All right, so where are you thinking since you suggested it? Middle of the tongue. I like it. Anything else we need to agree to? Can you agitate it with your tongue? Yes, no? No. What's your reason?
Because we won't know if it's melting due to temperature or if it's melting due to movement, something like that.
Okay, all right. So no, you just got to let it sit there. I hear this is going to taste good. Okay, all right. So let's give it a try. Here we go. 3, 2, 1. While you are sitting here, I want you to think about, is the heat going in or is the cold going out? And write down 3 observations you can make. Is the heat going in or is the cold going out? And how do you know? Folks, M&M lied to you, all right? They don't melt in your mouth. What are these people talking about? All right, you can go ahead and chew yours now. Many of you are like, ugh, like, that's not good. So it's true, no, these aren't really melting in your mouth. And if they did, they would certainly take a while, all right? But it's something that, 2 things. Number 1, gets kids to think about what is going on in there. What is making something melt, as opposed to just setting an ice cube on the table and watching it, which I gotta be honest, it's kind of like paint drying, not that exciting, all right, versus being able to do it. I will tell you that we used to use this as kind of the kickoff of thermal energy transfer. What is happening in your mouth? Is the heat going out or the cold going in? This was a big misconception for my students, and so it was easier to highlight in an easy way where they could start to actually make direct observations about something they were experiencing to be able to share back and forth. What do you think and why in a 1, 2, 3? So you've got to have 3 reasons, 1, 2, 3, as to why you actually believe what you're talking about. What's causing the variation in melting time? I used to make them actually sit there until the very end, which, by the way, it takes between 5.5 to 8 minutes to get 1 M&M to melt all the way in your mouth. And so in terms of that, what causes that melting time? How do we change it? Ideas. Does it matter if I have a peanut M&M? Does it matter if I have a mint one or one of the dark chocolates? That there were a bunch of different things that could play into. So how do we test that? And how do we, control some of these variables in terms of that? Do all chocolates behave the same? And how do we test this? Right? This was a really great experience if you knew your principal was out taking tours for the day, because the kids would be sitting quietly and writing, and you'd be like, woo, I'm a good teacher, because you knew that that was what they were looking for, because they have a rubric that's still like from 20 years ago. So this was something that's super, super easy to be able to do with kids. It gets at all of these basic ideas, and folks, it cost me the cost of a bag of M&Ms. All right, now, for people who are like, no, I cannot have candy out to kids, like food allergies, all of these different things, I have done this before with like juice ice cubes. So you can do it with, throwing in a little bit of apple juice or orange juice to be able to, avoid the you gave out candy label in your classroom. The other thing that I highly recommend, so Hershey Kisses, by the way, work the best. They're more expensive than M&Ms, which is why you get M&Ms here today. The other thing I'll recommend, that if you're looking to buy anything that is sold on a grocery aisle, candy aisle, that you buy right after February 14th, or right after October 31st, because that's when they put everything on sale, and you can usually get a bunch of stuff at like half price because it's wrapped in a different color. So other quick connections that you can make with kids that are very, very simple in kind of this easy introductory way that center around food. We do Now That's Sweet. How many of you have seen like the Mio or the Crystal Light like water flavoring, yeah? Okay, so those things are really cool. I used to do it with Kool-Aid because we didn't have Mio at the time. But those are really cool to be able to look at different percentages of creating solutions. So especially when you're trying to build that skill set early on of how do I create a solution and having some reason behind it, it's a good way to introduce that piece to the kids. The Mio bottles work great because they're based on drops, and so then they don't even have to actually measure out very specific pieces to be able to create different amounts of solutions, and then which one, how do they react differently, and what's the difference when you have more, less, somewhere in between. Kool-Aid works well if you're really focused on having them be able to measure out a specific substrate that then they're going to add into solution. So it helps just refine that skill if you actually have like the dry powder as well. Aside from now that's sweet, oxidation termination. So this is how we'd highlight the difference between qualitative versus quantitative observations of apple slices as they go brown over time. How do you look at something and take a qualitative observation, it's turning more brown, and turn it into something that's quantitative? I've seen a ton of different solutions to this that the kids will come up with. And especially now with the use of technology that they have available through their phones, they've been able to use devices like iPads and different things to be able to download apps that allow them to measure the different light quality and consistency of different objects that are used for photography. That was one of the most recent ones I saw. Before the day and age of apps, I would see them do this with like paint tiles, where they'd be like, okay, so I'm going to bring in a whole host of paint tiles and be able to match them up based on the different changes in pigments to be able to make a quantitative observation. But again, a good way to highlight it as opposed to just saying qualitative is with words, quantitative is with numbers. Looking at the difference between the two and having your kids actually create some of these ideas around how can I go back and forth between those two worlds. Ghostbusters, so this is a pretty famous one, the syringe and the marshmallow, to talk about gas exchange and Boyle's law. If you haven't seen it, it's an easy thing to YouTube. What happens to marshmallow when you stick it in a syringe and then pull the edge of the syringe, and how that food changes and why does it change, what's making up that marshmallow, to be able to look at some of the gas laws that can be occurring to use to describe that actual engagement. And then food packaging. This is a really cool engineering one, and especially with engineering being a lot more prevalent in science these days, depending on where your state is in regards to the next generation science standards and the K-12 science framework. The engineering of food packaging is actually really interesting. So how do you use different shape, mass, volume, materials, and how does that impact actual marketing and sales associated with it? Especially if you have a really cool math teacher who's doing things with geometry, this is another really great way to kind of tie those pieces together so that they see how this influences that world around them. Okay, so I have to do it. There's even STEM in food. That's my corny joke for you for today. I don't have any others, so that's okay. If you look at food and you're like, man, we're all about STEM, 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 which is the big word that's being thrown around, it's easy enough to hit those activities or those ideas through here. The popcorn lab, which was one of the originators of this whole idea, the idea of making popcorn in class. Science, I used it for mass versus volume. So this is articulated in chapter 2 of the book. What's the difference between mass and volume? Okay, well, it's something that as a science teacher, I have a really easy time explaining. But why would that matter in any way, shape, or form? So having them look at the mass of the popcorn before and after, and some of that conservation type of an experience versus that there's a change in volume, which is visible. And how do you use those words in a context that makes sense to them? Technology, we used to do a piece with microwave technology and how does this work. How many of you have ever popped popcorn in a microwave? Okay, you might note that there's a certain side that says this side down, yes? So I used to always tell my kids, okay, let's be rebels and do it the other way. And so they'd be like, really, we're gonna do this? I mean, it was like I had literally, you know, told them I was about to turn the key on the atomic bomb. They were like, oh, I just don't know if we can. And I was like, we can, let's do it. Let's push the limits of what's allowed. And so I'd always walk up and they'd gather around the microwave and I'd set it in there and I'd close the door and I'd push it and I'd run. And they were like, oh, you know, and I'm like, no, 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 it's really fine. But just to kind of get their hearts going, it's again something that they've never considered. What does happen if I flip it the other way? I encourage you to try it. I'm not going to tell you what happens, but I think you'll be surprised. That's what I'm saying. Reverse engineering then on microwave popcorn bags. So once we've done that, then we would cut it open and be like, all right, so what is going on in here? To be able to look at the actual internal workings of a microwave popcorn bag, it's pretty simplistic. And kids actually have the ability to look at it and talk about, okay, so why is this here? What role is it playing? And how does it impact the actual popping of the popcorn? From there, it's actually possible for them to create their own version of a microwave popcorn bag to be able to try out. And again, engineering those pieces to put it together themselves to be able to understand that process and the science behind it. Math, again, just kind of solving for an equilibrium, right? If I have an expectation that mass is conserved, how is that appearing in this particular scenario? And if it's not conserved, where am I losing something? And identifying that to be able to build upon those math skills. Plus, everyone loves a good movie snack. It's super yummy. So in Exploding Corn, we talk about what happens if you have too much energy. You explode, all right? And we talk about, especially with kids, how many of you have had too many pixie sticks before, you know, or eaten a couple too many sweet tarts and then you're just through the roof, okay, to be able to have that as a context for this discussion. When's the last time you ate popcorn? If you're ever doing a food lab, ask them. When's the last time you had this? Okay, it again creates that experience and that community connection that's important when we talk about food. The focus really in this one is physical science. So again, volume, mass, conservation of mass and energy, depending on the level and the grade level you teach. Some of these concepts are going to be more appropriate than others. I encourage you to find the one that makes sense for you and not try and do all of them, because then you get to a point where it's like, we're doing popcorn again? And you're like, yes. So we don't want these things to drag out for, you know, years and years and years. Figure out what it fits best with in your curriculum and run with it. And it does include math and data analysis. I like to have them do compare and contrast with Venn diagrams. I think those are super helpful in regards to, so what's similar about mass and volume and what's different about mass and volume? And what are the characteristics between those two? It again helps you as a teacher identify some of those misconceptions so that you can address them in your instruction in the classroom. So safety highlights, you can do Bunsen burners or hot plates. If you have younger kids, I highly recommend hot plates, not the Bunsen burners. But if you have older kids, lighting that Bunsen burner is something that they look forward to every day. I was in a chemistry class once where we never lit the Bunsen burners, not once. And I was like, what? Like, we have this amazing facility here and we never get to light them. So it seems silly, but it is something that kids look forward to, that particular piece. So why not make use of those materials and give them exposure to them in terms of that heat source, because you can do it in a controlled and safe way in the classroom. The foil can pop off the Erlenmeyer flask, so goggles are a must. I used to have my kids wear goggles no matter what activity we were doing, even when we were just doing basic levers in the classroom. So I wasn't really worried about anything flying into their face because these are big old 2x4s. I'd have them wear goggles. Again, it's just something that helps them get used to this idea of making sure they're taking safety precautions. I also like to say, can you prove to me you can wear them for a full class? And they were like, yes, I can. And it just became part of what we did in the classroom, so that when we were engaging in things like this, where I had concern for their eyes, that they were like, it's not a big deal, as opposed to, my eyes can't breathe, which I heard often from 8th graders. Sterilized workspace for potential spills when transferring the popcorn. You do want to make sure that even though it's popcorn, you don't want to just have them like throw it on tables because they can pick up who knows what sorts of stuff. There was really an interesting article recently that came out about how true is the 5-second rule when you drop something. And if you haven't seen it, I encourage you to Google that, because it's a good context for talking with kids about, so why do we make you take these safety precautions? And what difference does it make in terms of what you put in your mouth? Broken glass can occur, so it's always a good idea to have a plan ahead, step in preparation. If the glass breaks, what are we going to do about it? Whenever I engaged in kids with things that could be dangerous, I always ask them to tell me, so what are the safety things that we need to be aware of? I can stand up here and tell you what they all need to be, but they probably weren't listening to me. And so it was better for me to say to them, you tell me, after having read this experience, what do you think we need to do to be safe? Because it helped me check, did they actually go through the process of looking at this ahead of time? And if there were crickets, I knew, well, then we're just not going to do this today. Let's focus on kind of preparing so we can do it in a safe way. So science content connections, we talked about the mass volume and conservation. How are these items measured? Because they are measured differently, and it helped introduce the tools associated with that. How do these change throughout the process? And then introduces the idea of energy and the impact of temperature can have, such as creating pressure. And they were always shocked that the little foil would pop off the top. And it's like, so, but why does that happen? Again, introducing questions that then they can follow up with and answer and help create a context for. As far as phase change in water, if you want to go a little bit deeper, if you're doing this as part of a chemistry experience, I'll be honest, this is a lot more exciting than boiling an ice cube. Okay? Because it gives them that opportunity to say, what is changing in the water and what difference does it make? What happens if I heat the popcorn ahead of time to remove some of that moisture content? Does it still pop, and how is that impacting this process? Again, physical versus chemical change, it's a great debate. You'll actually find science resources on either side of this. Where they say, like, no, it's for sure a chemical change, because you can't go back from once it's popped to bringing it back into the seed in the original format. At the same time, is it chemical change, though, because it's water vapor that's driving this process. Right? So it's interesting to have the kids kind of talk about that back and forth, and brings back a lot of those early discussions about chemical versus physical change, but in a way beyond just having them look at burnt bread and a melting candle. Ballpark pretzels, so I'll hit this one pretty quickly. Basic safety highlights. This was one that we usually did at the end of the year. Again, you can use Bunsen burners or hot plates. I always used hot plates when we were cooking anything, because you can create kind of a self-contained solar oven type container. Sterilized workspace for handling of dough. This one was always entertaining because you needed to make sure everything was clean. And it was a 3-step process. So we prepared, because this one focuses on biochemistry and the yeast, and some of the different functions that the yeast is playing in the particular food items, especially bread-based items. We would prepare the wet mounted slides, either one per group, so that we could share out results ahead of time while we were waiting for dough to rise. Or you can have the kids prepare the wet mount slides depending on their expertise and experience with that. You can prep sucrose solutions ahead of time and dropper bottles to label them. Again, it just helps to expedite the experience. One of the things we focus on in Gourmet Lab is that not everyone's going to have a block lab period, and so sometimes you need to be able to do these in shorter chunks and break it up. One of the other things we used to be able to do in terms of implementation would be working as a single class versus working as a group. So sometimes I would have 2 groups contribute to a process. So one would take it through the beginning, another would take it through the end, and then they'd be able to kind of share out on the different parts of the process they participated in if you don't have a full 90 minutes for some of these pieces. You can also, in terms of cooking things, I used to always do school supplies versus toaster ovens. I just had toaster ovens. I went around to a couple garage sales and got several toaster ovens that then I was able to use for like $5 each. They were pretty cheap. Even in the store, in our grocery stores, toaster ovens tend to cost for around $19. So it wasn't something where I was going to go buy like all brand new ones with my science budget, but it was something I was able to say, hey, does anyone have an old toaster oven they're getting rid of? Especially with a lot of the new technology, it was something that community members were able to donate, and we cooked in those versus the school ovens. Some cafeterias are a lot nicer about it. It depends on what kind of a relationship you have with your cafeteria lady as to whether or not they'd be willing to let you use that particular resource. Student connections, so we were really talking about fermentation by the yeast and looking at the role that that was playing. What are environmental needs for yeast? So we used to talk about what could we do to this classroom to be able to make it the coolest classroom in the school. And that's how we'd start with that conversation. And they would talk about all the different things they would want in the coolest classroom in the school. We want you to have couches. We want you to have a gaming system. We need TVs. And talking about those different pieces and how does that translate to different organisms and what they're looking for in regards to environmental conditions that are ideal. Moving that ahead, the idea of carrying capacity for populations based on resources available. At what point does the cool classroom get so full of kids that you don't want to be there anymore? Because there's too many people there who are all trying to take access to this, and you're like, forget it, I don't want to be involved in that, right? And how does that play out in our environment? And then the rearrangement of molecular structure for gluten in this case. Again, this is going to be a little more on the higher level piece if you're working with students in the high school or in AP or honors classes, but really looking at how changing a molecular structure actually changes the final product of the bread. So what happens if you don't knead it? What is happening when you knead it? What happens if you don't let it sit and letting it go through that full process to look at how the actual molecules of gluten are changing and how that relates to your final piece? Again, physical versus biological changes. If you want to take it that direction, if you have a younger student audience, it's a good way to look at it. So student handouts, each of the gourmet labs does have a student handout. It really starts with that kind of personal experience, trying to engage them in that piece. One thing I will tell you, it does have a background that we encourage you to share with kids. You don't have to share it in a reading format. You're welcome to share it in kind of a verbal way, and we talk about both in terms of the teacher engagement piece as well as the student. Each one will go through kind of a basic process of looking at a hypothesis for what's happening. After the hypothesis, asking them to look at materials and procedures. There are two separate ones involved with the ballpark pretzels because it's further on in the experience. These activities are meant to either be done as individual, as needed, or as a progression as they're presented in the text. So either one, depending on what the needs are. They do ask for data and observations throughout, oftentimes looking at both qualitative and quantitative observations for kids. Then graphing that, presenting it into that visual format so that it's easily accessible to a consumer. And then conclusions and connections so that they can start to draw it back to not just making conclusions from their experience, but how does that connect back to this initial idea we were talking about in regards to creating an ideal environment. When you're experimenting, it engages students to think about the step-by-step procedure. And again, it's a great reason to look at cooking as a really great way to engage kids, especially early on or in the middle of some of your other topics. It is very procedures-based. You don't have to stick with just labs that are in this book. You can really look at any of the recipes. We used to have students who could bring in their own, and we dissect it for the science that was happening in that recipe. So looking at the different chemicals that were in play in the recipe, as well as what type of changes were occurring in looking at the science of heat and temperature transfer. What data can you gather from kitchen products and how does that impact your final product? And then would you want to repeat the process to improve your outcome? So generally they'd try it once, they would have a lot of errors, and they talk about, okay, I'm going to go try this at home because I struggled here, but I've learned from that and I want to do it again. And then how does it connect to your life? When you look at the teacher pages, you'll see that there are standards identified. They do come from NSES because this is a text that was published before NGSS. So in terms of making some of those references, most states you're going to have to do some sort of editing yourself as well to be able to see where it aligns with your specific needs and curriculum and grade level. There is a vocabulary piece, materials decoded for the grocery store so that you as a teacher can walk into a grocery store and just pull the pieces you need. Safety highlights preparation, what do you need to do ahead of time, and then move into how do you introduce this and how do you implement it in the classroom. So that's pretty clearly articulated so that you feel better about engaging in it the first time as opposed to just kind of jumping in blind and saying, I don't know what to expect. This highlights a lot of the things that you'll see with kids, questions you'll be asked, as well as potential snafus that can occur, especially your first time through. There is a data analysis and answer key, conclusion and connection ones, again, just to make it easier for implementation. And then we do highlight cross-curricular notes for math, literacy, and technology so that you can do some outreach there to connect with other classes and topic areas. There are optional extensions for middle school and high school students. I know a lot of folks have used this successfully in working with either an after-school group or an after-school club, having them go through and kind of take it to a next level with students. They are designed to help you feel more comfortable, no matter how good you are in the kitchen, that you have kind of that support behind you. And you can see a wide array of options. There were actually a bunch of teachers who helped pilot these, and we all talked about the different things we saw in our classrooms to be able to inform the text itself. And then you might be like, whoa, this looks like a lot. The labs are really varied, just so you know. So I presented to the popcorn lab, which is really pretty straightforward. You're popping popcorn. All the way to the pretzels lab, which can be a little more engaged depending on those content and topic areas. Just know that even though they're in this progression, it goes from easiest to hardest. So if you're looking at it based on especially building your experience in this approach, I start with the earlier ones before you jump ship to the later ones. They can be done individually. We talked about that. And there's lots of options to help you meet the needs of your classroom. So we talk about different ways to present as a demo or to present in smaller sections so that you feel comfortable. So my best piece of advice for gourmet labs, if you try this in your classroom, which I hope that you do in some respect, is ABC, always be cleaning. So I think it's one of those things where it's important to be able to say to the kids like ABC, 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 so that they know, oh, there is something that I can be engaged in and doing. Even though in cooking there is a lot of wait time that can be involved, if you have them living in this world of I must be cleaning, it makes it a lot easier for you. The first couple of times we were doing these, I was cleaning up every single period for like 30 minutes after what the kids could accomplish in 2. So it's just about holding them accountable so that they understand that that's part of the process, and it makes it easier, again, on you as a teacher and builds that accountability into the system. I talked about that there's a free chapter, so I do want to highlight that really quickly. NSTA sample book chapters are available for free online. So you may not know this because generally speaking, they do charge you for their text. But for all of them, they do present, if you go to the actual text itself, a free chapter that you can download and check it out. So I highlight this not just for this book, but actually for all of them, that if you're considering investing in a text, I know resources are slim, and so oftentimes it's good to be able to get a sample of what it is before you actually go through the process of purchasing the whole thing. Along those lines, the last thing I want to highlight is, can you write a book? So I was really surprised that NSTA Press was willing to take a book from a little old 8th grade science teacher from Salt Lake City, Utah. I always felt like, oh, the people who write these are like Roger Bybee, who's amazing, you know, and some of these other real industry experts where I'm like, wow, they are so cool. Folks, some of the best resources that are put out by NSTA Press come from teachers. And it's those teachers just being willing to say, you know what, I have some great ideas. They work with my community, they work with my classroom, and I really want to share them out there because maybe they'll help others. So from that piece, they do have a really easy place where you can go in and submit a manuscript. It's really pretty straightforward. They ask you for a book proposal form, an outline table of contents, and a sample chapter. That's it. You don't even have to have the whole thing written. So just your idea, and you can put it out there. And I just like to encourage any of our members of NSTA, it doesn't matter how long you've been teaching. If you have an idea that you think is worth sharing, I'd encourage you to pursue this because they need more teachers writing for them. Let's end where we started. So thinking back to everything in your K-12 experience and those qualities of the things that you loved about science in your K-12, are those things that you're incorporating into your classroom? And is it possible to do that through the lens of food? I really think that it is, and I'd encourage you to try it. Be it just a bag of M&Ms, some Kool-Aid on the side, maybe a little popcorn to get you going. So with that, let me just say thank you. I know it's Saturday, or pardon me, Sunday, and it's the very end of the conference, and I really appreciate you coming out and participating in today. So thank you. We'll stick around to answer any questions you may have.